students, very good evening to all of you. So welcome to Chakravyuh Series, and today we are going to discuss the most important MCQs from the chapter D and F block. So we have completed all the chapter MCQs. Today is the last chapter, and I know many of you will be busy in your preparations. So yes, we can start. Okay, I will be expecting less audience today definitely, because your final boards are there. You might be preparing for your Kannada exam or maths exam. Fine, you can watch this later as well. So I will be discussing the questions very soon. Okay, so I'll be starting with the first question here, that is, as the oxidation number of a metal in its coordination number in its compound increases. So if you see, the oxidation number is increasing, that means it will have a higher oxidation state, it can get reduced, and if it is reducing, it will behave as an oxidizing agent, right? So, and what happens next thing here, as the charge is increasing, so the polarization will increase, so covalent character will increase and the ionic character will decrease. Okay, so option number B is the correct answer. Hi Mr. Artist, hi Sumant, hi Bharat. Yes, all of you, good evening, a very good evening to all of you. And yes, cheat sheet of chemistry, definitely Bharat, we will try. I will make it, we will make in live class. Okay, we'll make, I want all of you, you'll be sitting with a pen and paper, I'll be making here, you will be making there, so that we can have a live class feeling. Okay, we'll be doing it. Okay Bharat, definitely. Next, moving to question number 2 here. Okay, Lekhana PDF we will be providing. There was some technical issue with that. Okay, do not worry. New link will be updated very soon. Okay, by today night or tomorrow morning, the new link for PDF will be given to all of you. Okay, please be a bit patient for that. Okay. Okay, next question. Potassium dichromate can be manufactured from? Yes, quickly you can answer this one. So we know this is a very important 3-marker question. So it can be prepared from chromite ore, that is iron ore. So that is chromite ore. Okay, question number 2, I think all of you have given correct answer. Next, the structure of dichromate ion is tetrahedral, 2 tetrahedral sharing one corner with CR-O-Cr bond angle of 126 degree, square planar and pyramidal. So if I see, the structure is like this. Okay, Cr2O7 2 minus, right? So it is like this. Okay, so this is a tetrahedral structure, this is a tetrahedral structure, and on one corner we have chromium, oxygen and chromium. So correct answer is option number B here. Yes, all of you please mention the answer with the question number. Okay, okay, so students, before moving to the next question, a small announcement here. As you all know, after the board exams immediately we have KCET examination, right? So for preparation of KCET examination, to help you with your preparation, we have 2 programs. One is your Lakshya KCET crash course. This is an offline course. So in the Diksha Vedantu centers situated in Bangalore, there will be offline classes. It will be residential as well as day scholar. So if you want hostel facilities also, you can join this program, and here also you will be getting complete syllabus, PYQs, doubt session, teacher presence, study hours, everything will be there. Now suppose you are not able to shift to Bangalore for this preparation, you just want test series, we have our Abhyas KCET 2025 test series. In this, if you just register, you will be getting 4 free tests. Apart from that, there will be 31 paid tests, which will include both part test and full length test. Okay, PU1 and PU2 syllabus will be covered. You will be getting one-shot revision videos. You will be getting last 5 years of chapter-wise insight, video solution analysis, everything. And these all things are just available at 1498 rupees. Now, why I am saying 98? If you add 1 rupee more, that is 1499, you can get access to our PU2 Success Blueprint test series. So this is the right time to purchase this one. If you are interested, go to the description section. You can find the link there. Okay. Now moving to the next one. Okay, next, acidified potassium dichromate oxidizes hydrogen sulfide too. So sulfur, sulfur dioxide, sulfur trioxide, all of this. So if you have H2S, that gets converted to sulfur. Okay, so correct answer is option number A here. right? Okay, next students, I will be answering all your questions at the end. Now no discussion between the questions. Okay, fusion of MnO4 with KOH and oxidizing agent KNO3 produces. So the first step of preparation, right? So what does that concludes? That includes your potassium manganate, potassium permanganate, both A and B, and none of this. So in the first step, potassium manganate is produced, that is K2MnO4. Right now, after hydrolysis we get potassium permanganate, so correct answer here is option number A here. Okay, next question number 6. Electrolytic oxidation of MnO4 2- in alkaline solution will give to you. So if you see here, yes, we have MnO4 2-, so if you do electrolytic oxidation, it gets converted to MnO4-, right? That is your preparation of permanganate ions through electric method, right? Option number B here. I think it is correct here. Okay, very good. 7th one, oxidation of Mn2+ ion salt by peroxo disulfate gives you. So if you have Mn2+, okay, and in presence of peroxo disulfate, Mn2+ gets oxidized to which of the following? Can you tell this one? Yes, waiting students. Oxidation of this one will give you what? So students here have some question regarding the my lectures in 1 marker, 2 marker. So yes students, definitely if you study these many questions, you can easily get a very good number. Okay, so do not have to worry for that. Okay, yes, let me tell me the answer for this question. Let me see if anybody has answer. 6th one, 7th. Okay, I have got C answer, B answer. Okay, the correct answer here is option number C. Okay, peroxo disulfate converts Mn2+ to MnO4-. Okay, 7 is option number C. Okay, okay, next question. Both MnO4- and Mn2,4- have which structure? Okay, can you answer this one? This is very simple question. Okay, I will write this reaction for you so that you don't get confused. See, Mn2+, okay, peroxo disulfate is S2O8 2-. This gets converted to MnO4- and SO4 2-. Okay, so here that is why we have +2 to +7, oxidation happens, it converts it to MnO4-. Next, both MnO4- and MnO4 2- have which structure? This is very simple and easy question. Let me see who has answered. 8A, yes, both are correct, that is tetrahedral structures. All of you are correct here. Next, acidified permanganate solution oxidizes oxalic acid to, this is important question, oxalic acid will get converted to what? I have written already, it will get converted to carbon dioxide. So option number A is the correct answer here, right? Yes. Okay. Next, question number 10, dark purple crystals of KMnO4 are isostructural with. So if you remember KMnO4, MnO4 structure is like this, right? MnO4-. This one is isostructural with ClO4-. Okay, the same tetrahedral structure is there. So correct answer is option number A here. Okay. Next, question number 11, neutral KMnO4 oxidizes iodide to. This is very important question, very important question. So if you remember, in presence MnO4- and if you have I-, in acidic medium it gets converted to I2. Okay, but if this medium is neutral, then what will happen? I- gets converted to IO3-, iodate ion. Okay, so correct answer here will be option number B. Yes, all of you are correct. Okay, very good. I2 in acidic medium. Okay, here it is given neutral medium. So neutral medium is IO3 minus. Please remember, acidic medium it is I2, right? Okay, students, let's move to the next question. Neutral KMnO4 oxidizes Mn2 plus in the presence of ZnO2. Okay, so if you have Mn2 plus, okay, and if you are having MnO4 minus, and you are having here ZnO, then MnO4 minus will oxidize Mn2 plus to what? So these all are there in the oxidizing property of KMnO4. In that reaction, that thing, these all things are there. So can you tell which one it will be? Yes, it is 12th. I can't find. No. 12th C. No, I don't think it is C. It is A, dear. MnO2. Mn2 plus gets converted to MnO2. Clear? 12C, I don't think it is correct. Students, please check this one. Tell me this one, but is it MnO4 2 minus or MnO2? In neutral medium you have to find. Yes, it is A. Okay, it is A, that is MnO2. Okay, but still I will check this answer, but I am sure it is MnO2. Okay, next question number 13. The gradual decrease in the atomic and the ionic radii from lanthanum to lutetium is called as. This is very simple and easy question. Lanthanoid contraction, actinoid contraction, shielding effect, all of this. So we have studied. This is a very, very famous, popular, most repeated, most expected question in your PU board as well. So that is your lanthanoid contraction. So for lanthanoid contraction, remember the definition, cause and the consequence. Okay, very, very important question. Next, question number 14. The almost identical radii of ZR and HF is a consequence of. Again, very simple question, direct answer. Shielding effect, actinoid contraction, lanthanoid contraction, or none of these. Which one will this one be? Again, just now we discussed, right? ZR and HF will have same. ZR belong to 4D series and this belongs to 5D series. Okay, now 4D and 5D both will have same amount of radius, that is because of lanthanoid contraction. Option number C. Yes, all of you are correct here. Next, the cause of lanthanoid contraction is due to, this is important again, imperfect shielding of one electron by another in the same shell, imperfect shielding of one electron by another in different shell, perfect shielding, perfect shielding. So we know it is not perfect shielding, it is definitely imperfect shielding, and imperfect shielding of one electron by another in the same shell. Okay, so when the electrons, the d electrons, because of its diffuse shape, they are not able to shield each other, or the 4f electrons are not able to shield each other, the nuclear power or the nuclear force increases, so side decreases. Okay, so 15 has to be A. Yes. Next, question number 16 here. The common oxidation state of lanthanides is very easy, +2, +4, +1 or +3. We all know it is +3. Okay, option number D here. Next, the composition of mic metal is, this is also a very important question. Lanthanide metals 95%, iron 5% and traces of sulfur, carbon, germanium and aluminium. Lanthanide metal 80%, lanthanide metal 60%, lanthanide metal 40%. So we know that in mic metal lanthanide have a contribution of 95%. So option number A is the correct answer. Okay. Next, we'll move to question number 18. Mic metals are used in magnesium based alloy to produce bullets, shell, lighter flint, all of this. So if you have watched my 2 marker series where I have discussed about mic metal and its application, I have told you the applications there. So it has to be all of this, that is option number D here. Okay. Next, question number 19. Ziegler-Nattler catalyst is. So this is there in the applications part of D&F block. If you study last portion, in the application part you can see it is TiCl4 plus trimethyl aluminium, trihydroxide aluminium, aluminium trichloride, aluminium tribromide. So it is your methyl group. So option number A here. Okay, very important question. So you should be knowing the formula correctly. Next, question number 20. The orbitals of the transition elements that protrude to the periphery of an atom more than the other orbitals is. So in the transition element, we know that the 3d electrons protrude out. Okay, the 3d electrons are present outside the like atom, means not outside, means they, suppose this is the atom, the 3d orbital are more towards the outwards, not towards the inside of the atom. So that is why correct answer is option number C here. Okay, next, question number 21. These questions I have taken from exemplar questions. So electronic configuration of a transition element X in +3 oxidation state is given. What is its atomic number? So if you see here, argon is having 18 electrons plus 5, 23 electrons. +3 oxidation means 3 electrons have been lost, so I will add 3 electrons, so it is 26. So the correct answer here is option number B. This is which element? Iron. Okay. Next, question number 22. The electronic configuration of copper 2 is 3d9, whereas copper plus is 3d10. Which of the following is correct? This is very important question. Okay, so now copper 2 is more stable, copper 2 plus is less stable, both are equally stable. Stable of Cu1 plus and Cu2 plus depends on the nature of the copper salt. Now if you remember one very important question, copper plus undergoes disproportionation reaction to give you Cu and Cu2 plus. So this reaction itself says that copper plus is unstable, whereas copper 2 plus is very stable. What is the reason for this one? Copper plus no doubt has D10 configuration, right? But copper 2 plus has very high negative hydration enthalpy. Okay, due to this one, copper 2 plus is more stable. So I can say that copper 2 plus is more stable is the correct answer. That is option number A here. Okay, clear? Okay students, any doubt here, please put down. Yes, Lakshmi, 22, you are correct. Next, question number 23. Metallic radii of some transition elements are given below. Which of these elements we have the highest density? So you can see iron, cobalt, nickel and copper is given. Now we have density is equal to mass by volume, and if you see the size is almost same, right? So volume does not have that much impact because you can see almost size is same in picometer. Now what is the mass? If you go along the period, mass is increasing because atomic number is increasing. So if mass will increase, density will also increase. So I can say iron, nickel, cobalt, copper. So copper will have the highest density, that is option number D here. Okay, yes, I think all of you are getting this one. Next, question number 24. Generally transition elements form colored salts due to the presence of unpaired electrons. Which of the following will be colored in the solid state? Very important and easy question. Okay, so yes, now if you see here, Ag is in +2 oxidation state. Okay, copper is in copper is in +2 oxidation state, Zn is in +2 oxidation state, copper is in +1 oxidation state. Okay, so now 1 second. Okay, this is Ag is in +1 oxidation state. Okay, yes, +1. So if you see here, the configuration is 4d10, here +2 it is 3d9, here it is 3d10 and here is also 3d10. So if d10 configurations are there, then there will be no unpaired electron. For color, what we need? We need unpaired electrons, right? Now d9, what is the configuration here? If I draw d9, 1 2 3 4 5 6 7 8 9, we have one unpaired electron which can undergo dd transition to give you color. So which compound will be colored? Option number B here. Okay, clear? Okay, next, question number 25. On addition of a small amount of KMnO4 to concentrated H2SO4, a green oily compound is obtained which is highly explosive in nature. Identify the compound from the following. So this is from the reactions of KMnO4. This green oily compound is nothing but Mn2O7. Okay, so you might not be knowing this answer, so please note down this question. Okay. Next, moving forward, question number 26. The magnetic nature of elements depend on the presence of their unpaired electrons. Identify the configuration of transition elements which shows the highest magnetic moment. So D7, D5, D8 and D2. Okay, I cannot find students answering now. We have already reached 26th question. So students, please answer. These are very simple and easy question. Please answer. Okay, so now if I see here, highest magnetic moment, right? That means what? Magnetic moment formula is what? Root over of n into n plus 1. If n value will be higher, magnetic moment will be higher. So the highest possible value of n is 5. Okay, n cannot be more than 5. So in that, like for example, for D block, okay, for D block elements, n can highest value be 5. So in 3d5 we have 5 unpaired electrons, so it has to be option number B here. Okay, yes Akash, very good. Next, question number 27. The trivalent lanthanoid ions to be colorless is or are. So which lanthanoid? Trivalent means which lanthanoid? L3 plus. Okay, lanthanoid we represent like this, Ln 3 plus will be colorless. So here the answers are, your options are EU. So you have to think like this: EU plus 3, La plus 3, Er plus 3 and Ce plus 3. Okay, so if you have observed or if you have remembered the electronic configuration, La3 plus has no unpaired electron. No unpaired electron. If there is no unpaired electron, no transition. You can say in lanthanoid we have FF transition or DD transition. Whatever, there is no transition, so it is no color or colorless. So option number B here. Okay. Next, question number 28. Which of the followings are disproportionation reaction? So you can see a disproportionation reaction means same element undergoing oxidation and reduction, right? So if I have copper plus here, it is getting converted to 2 plus and it is getting converted to Cu. Plus 1 to plus 2, plus 1 to 0. So that is definitely undergoing oxidation. So I will write it like A, B, C and D. So A has to be there. I can eliminate this option where there is no A. Now if you see here, MnO4 2 minus, this is plus 6, this is plus 7 and this is plus 4. So plus 6 to plus 7 is oxidation, plus 6 to plus 4 is reduction. Again it is undergoing disproportionation reaction, so B also has to be there. I can eliminate this option. Now we have to check C. If you check C here, KMnO4, this is plus 7, okay, this is plus 6 and this is plus 4. So here plus 7 to plus 6 is reduction, plus 7 to plus 4 is also reduction, right? So that is why this is not a disproportionation reaction, only A and B, that is option number A here. Okay. 28 will be A. Yashashwini, it is A. C is not, see, plus 6 to, you have here, sorry, you have plus 7 to plus 6, plus 7 to plus 4. See, plus 7 to plus 6, plus 7 to plus 4. This is also reduction, this is also reduction. That is not disproportionation reaction. Disproportionation reaction means one has to be oxidation, one has to be reduction. Okay, so it has to be only A and B. I hope this is clear. Next, question number 29. When KMnO4 solution is added to oxalic acid, the decolorization is slow in the beginning but becomes instantaneous after some time because. So if you remember, oxalic acid, right, it will be oxidized to CO2 by KMnO4, and KMnO4, when it is oxidizing, KMnO4 itself is a purple color, bright purple color. When it is oxidizing, it is getting converted to Mn2 plus and it loses its color. Okay, so initially what happens, the color loosening will be slower, okay, but once Mn2 plus start forming, this Mn2 plus act as a catalyst for this reaction, and that is why the rate becomes, or the instantaneously you can see the color change. So that is because Mn2 plus acts as auto catalyst. Okay. Okay, next we'll move to question number 30 here. Students, I cannot find participation today. There are 14 elements in the actinoid series. Which of these element does not belong to the series? So you have to remember all the 14 actinoids, and if you have remembered, then you must be knowing that Tm belongs to lanthanoid series and not to the actinoid series. Okay. Next, question number 31. KMnO4 acts as an oxidizing agent in acidic medium. The number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ions in acidic solution. This is very important question. I am giving you 2 minutes time. Please solve this question and tell me the answer. All of you, please take your time, solve this question and then answer this one. Just let me have some water by that time. Sheetal, PDF link will be given to you. I told you in the starting of the class, new link will be provided, so please do not worry, it will be provided to you soon. Okay, now please solve this question. Anyone? Nobody has given me the answer yet. (31A). Yes, Shri Gauri Yardal, very good, you are correct here. I will be explaining, this is important question, please watch carefully. So first of all, what happens, sulfide ions means, if I have KMnO4, I can write it as MnO4 minus C. Very important question, all of you please watch carefully. MnO4 minus is there, okay, and I have sulfide ion, and this one we know it will get converted to Mn2 plus, and this one will get converted to sulfur. Now if I see here, okay, this is plus 7 to plus 2 is 5 electrons. Here if I see S2 minus 2 is 2 electron. The number of electrons lost and gained should be equal, so I have to multiply this equation with 2 and this equation with 5. So if I multiply that one, what will I get here? 2 MnO4 minus reacts with 5 S2 minus, right? So I can say that 2 MnO4 minus can oxidize 5 S2 minus. 2 MnO4 minus can oxidize 5 S2 minus. The question is asking the number of moles of KMnO4. So in other words, I will say like this, the number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ions. So I can say now that with 5 moles of sulfide ions, 2 moles of MnO4 minus is reacting. With 1 mole of sulfide ions, 2 by 5 moles of MnO4 minus will react, right? So 2 by 5 means that is your option number A here. Okay, very important question. Okay, clear? Next, question number 32. Which of the following is amphoteric oxide? This is very direct question, Sheetal. I already said you that PDF link will be given, new PDF will be provided, link will be provided in the WhatsApp channel. Please do not worry, everything will be provided by today or tomorrow morning. Okay. Next, amphoteric oxide. You know what is amphoteric oxide? Oxides which can show both positive and negative, which can react with both acids and bases, right? So here if you see, so many compounds are there, Cr2O3 and V2O5. These are amphoteric oxides which can react with both acids and bases, so that is why option number A here. Okay. Next, I have question number 33. Interstitial compounds are formed when small atoms are trapped inside. Which of the following is not the characteristics of interstitial compounds? So they have high melting point in comparison to pure metals. They are very hard. Yes, Varshu, you are correct for 32 question. Okay. Yes, Lakshmi, very good. Okay. They retain metallic conductivity. They are chemically very reactive. So interstitial compounds, we know transition elements can form interstitial compounds, right? Now they are very hard, so when the gaps are filled, automatically it will become very hard. They have high melting point and boiling point because of increased molecular forces of attraction. They retain the metallic conductivity, but yes, they are chemically inert. Okay. So here, which of the following is not the characteristic? Option number D here. Yes. Varija, Yashashwini, Varshu, all of you are correct here. Next question number 34. The magnetic moment is associated with spin angular momentum and orbital angular momentum. The only magnetic moment value of Cr3 plus. So Cr3 plus magnetic moment you have to calculate. 2.87, 3.87, 3.47 and 3.57 bm. Bm stands for Bohr magneton, the unit of magnetic moment. Yes, very easy question this one. We know Cr3 plus configuration is what? D3. Magnetic moment is root over of n into n plus 1. That means root over of 12. But you do not have to remember this one. Okay, I will be telling you a trick here. See, if the unpaired electron is 1, magnetic moment will be 1.4. If it is 2, it will be 2.8. If it is 3, 3.8. If it is 4, 4.9. If it is 5, it is some 5.9. So you should remember this number. So 3 is there means immediately it will be 3.8. So I have option number B here. Okay. Yes, all of you are correct. Next, question number 35. KMnO4 acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with Ki, iodide ion is oxidized to. I have already discussed this question. Now everybody should be giving the correct answer. 34th, Varija, Varshu, Kiran. Yes, all of you have given correct answer. Varija, seeing you after a long time. Some of the classes you were not there in the middle. Okay, so if you see, I think everybody should be able to answer. Just now we have discussed MnO4 minus, right, in acidic medium gets converted to Mn2 plus and converts I minus to I2. But if I have MnO4 minus plus I minus in neutral medium, I minus will get converted to IO3 minus. So 35 has to be option number C here. Okay. Next, question number 36. Which of the following statements is not correct? Okay, be very careful in these type of questions. You always have to find not correct or correct statement. The first one, copper liberates hydrogen from acid. Second one, in its higher oxidation state, manganese forms stable compounds with oxygen and fluorine. Mn3 plus and CO3 plus are oxidizing agents in aqueous solution. Ti2 plus and Cr2 plus are reducing agents in aqueous solution. So I can see the first statement. We know copper cannot liberate hydrogen gas. Why? Because the reduction potential of copper is higher than hydrogen. Okay, so that is why here the correct answer has to be option number A. Okay, 36A. Next, question number 37. When acidified K2Cr2O7 solution is added to Sn2 plus, then the Sn2 plus changes to. So this is also a very good oxidizing agent. It will oxidize Sn2 plus to what? Sn, Sn3 plus, Sn4 plus and Sn plus. So it is Sn4 plus, that is option number C here. Okay. Next, highest oxidation state of manganese in fluoride is +4, but highest oxidation state in oxides is +7. This is because fluorine is more electronegative than oxygen. Fluorine does not possess d orbitals. Fluorine stabilizes lower oxidation state. In covalent compounds, fluorine can form single bond while oxygen can form double bond, right? So I think all of you will be knowing this one. Higher oxidation states are stabilized by fluorine and oxygen, and generally fluorine can form single bond whereas oxygen can form double bond. So option number D is the correct answer here. Okay. Next, question number 39. Although zirconium belongs to 4D transition series and hafnium belongs to 5D transition series, even though they have similar physical and chemical properties, because, okay, so that is, we all know that they have Lanthanoid contraction. Both belong to D block, both have same number of electrons, both have similar atomic radius, both belong to the same group of the periodic table. Yes. Very good, Yashashwini and Varija. I can see all of you answering. 39 is C. Very good, Varija. Both have similar atomic radius. Now, why do they have similar atomic radius? Because of Lanthanoid contraction, right? This is one of the main consequence of Lanthanoid contraction. Okay. Next. Why is HCl not used to make medium acidic in oxidation reactions of KMnO4 in acidic medium? Okay, so suppose we are doing some reaction in which we need acidic medium. Okay, we want to oxidize one substance. I have taken oxidizing agent as KMnO4, and to make that medium acidic I cannot use HCl or hydrochloric acid. What is the reason for that? Both HCl and KMnO4 act as oxidizing agent. KMnO4 oxidizes HCl into Cl2, which is also an oxidizing agent. KMnO4 is a weaker oxidizing agent. KMnO4 acts as a reducing agent. So yes, I know the answer. I think many of you will be able to answer this one. The answer here is 40B. KMnO4 oxidizes Cl. Here HCl, in that Cl is in Cl-1 state, right? It oxidizes this one to Cl2. Okay, so that is why the reaction, we cannot take HCl to acidify the medium. Next, the element having minimum volatility among the following. Minimum volatility. Okay, minimum volatility means not volatile. If it is not volatile, that means strong interatomic force. Strong interatomic force can happen if we have more number of unpaired electrons. Okay. Now, if you see, more number of unpaired electrons are present in the middle of the series generally. Okay. So, we have chromium and tungsten in the middle of the series almost, where the number of electrons, unpaired electrons, is maximum. Now, if you see 3D, 4D and 5D. 4D and 5D have more interatomic forces than 3D. So, if I compare chromium and tungsten, tungsten will have more interatomic forces. More interatomic forces means what? Very strong bonding or less volatility. So, that is why option has to be option number B. Yes, Kirtana, very good. Varija, very good. Sharath, it will be B. Okay. Next, question number 42. The correct statement among the following is: metals with very high enthalpy of atomization tend to be noble in their reaction. Metals with very low enthalpy of atomization tend to be noble in their reactions. Metal with very low enthalpy of ionization tend to be noble in their reaction. Metals with very high enthalpy of atomization tend to be highly reactive in their reactions. Yes. Okay. So, if you have very high enthalpy of atomization, means you need very high energy to break that bond. Okay. So, those type of metals cannot react easily. Okay. They tend to remain noble in their reactions. Okay. They are very inert in the reactions. So, here the correct answer will be 42A. Yes, Varija, absolutely correct. Very good. Next, question number 43. The element with least density. So, I told you along the period, the size is almost same, doesn't play that much role as compared to masses. So we have solved a question on highest density, this question is on least density. So yes, can you guess which one will have the least density? Scandium has the least mass, right? It is the first element in the series. So that is why least density will be for scandium. Okay. Next, question number 44. Exchange energy is approximately proportional to the. This is also very important question. Exchange energy, where do we use exchange energy? So if you have remembered, electrode potential or ionization energy depends on certain factors, and one of the factors there is exchange energy, right? So what does exchange energy mean? Exchange energy is proportional to the total numbers of possible pairs of parallel spins in generate orbitals, total number of possible pairs of anti-parallel spins in degenerate orbitals, total number of possible pairs of parallel spins in degenerate orbitals, total number of possible pairs of parallel spin in the generate orbitals. Now degenerate orbitals means what? The having same energy level, orbitals having same energy level. Now exchange energy is proportional to how many ways you can fill these electrons with parallel spin. Okay, so it is total number of possible pairs of parallel spins in the degenerate orbitals. That is option number C here. Okay, 44 is C. Yashashwini, it is C, because here it is giving anti-parallel spins. No, for exchange energy we need parallel spins. Next, question number 45. The ability of fluorine to stabilize the highest oxidation state of transition elements is due to low lattice energy and high bond enthalpy, high lattice energy and high bond enthalpy, high lattice energy and low bond enthalpy, low lattice energy and low bond enthalpy. Yes. Yes, Varija, very good. 44 will be C. No, Varija, 44 will be C. Yashashwini, 44 will be C. Now 45, if you see, ability of fluorines to stabilize the highest oxidation state, it is due to high lattice energy and high bond enthalpy. Okay, Gauri, very good. Gauri, 45 will be B, not C. Okay. Next question, very important, correct increasing order of oxidizing power. So here you should remember, oxidizing power is inversely proportional to oxidation state. Okay, higher the oxidation state, better is the oxidizing power. Now if you see here, I have what compounds given? VO2 plus. So if I see here, oxygen vanadium oxidation state is +4. Next I have Cr2O7 2 minus, here the oxidation state is +6, and next I have MnO4 minus, here the oxidation state is +7, right? Now what happens if you see +4, +6 and +7, higher the oxidation state, better is the oxidation potential. So MnO4 minus has to be highest one, so I can eliminate these two options. Next, if you see, next has to be Cr2O7, so only one option is left. So correct answer is option number A here. Okay. Next question number 47, the basic oxide among the following. This is also very important question. So you should be knowing that highest or larger oxidation state means the compound will be acidic. Okay, and if it is lowest or small oxidation number, okay, oxidation state, then it will be basic. Okay, now if you see here, the oxidation state of chromium is +6, here it is +3, here it is +2, and here I can say CrO4 +8, +8 is not possible, this is also in +6 state. So that means the lowest one will be more basic, so that is why your correct answer for this one will be option number C. Okay, very good Varshu and Varija. Next, the radius of La3+ is 106 picometer, which of the following given values will be closest to the radius of Lu3 plus? Yes, very important as well as easy question. So you have lanthanum and you know last element is lutetium, and you know along the period size will decrease because of what? Lanthanoid contraction. So if this one La3 plus is 106, what will be the closest value of Lu3 plus? So you can see here it will decrease, right? So I cannot have 140, I cannot have 160, I cannot have even 106. So what has to be the correct answer? 48 will be option number D. No Varshu, it is D. Okay, Mohammed Roshan has a question here, how to calculate the oxidation number. So dear, you can just remember oxidation state of oxygen is -2. Okay, so here I have 3 oxygen, I'll take this one as X. 3 oxygen -2, that means -6 is equal to 0. So X will be equal to +6. Similarly, if you see here chromium, I'll take chromium as X. There are 2 chromium, so 2X minus 6 will be equal to 0. So X will be equal to +3. Okay. Now here oxygen is -2, so X minus 2 is equal to 0. X is equal to +2. Okay. Clear? Next 49. Although +3 is the characteristic oxidation state for lanthanides, but cerium shows +4 oxidation state because of. So if you remember, cerium, okay, has a common oxidation or a stable oxidation state of +4. What is the reason? Cerium +4 has less stable half-filled 4f configuration, 4f7 orbital. So if you remember, 4f7 is exactly half-filled, so it cannot be less stable. So obviously by seeing this word itself, I can eliminate this option, right? Next, cerium +4 has more stable half-filled 4f7 configuration. This may be the answer. Cerium +4 has noble gas configuration with 4f05d0 and 6s0 configuration. Cerium +4 has more stable completely filled 4f14 orbital. So if you know the electronic configuration, cerium has this configuration, that is 4f1, 5d1, 6s2. Okay, so in case of +4, what will happen? All will this vanish or will go 0. So it will have a noble gas configuration. So option number C here. Yes, very good, Nalini, Pavan. Varija, it is 49C. Last question, students. In chemical behavior, lower members of lanthanides is similar to metal X and higher members resemble metal Y. Metal X and Y are. Yes, this is also important question. So if you have seen lanthanides, okay, and if you have lutetium, so lanthanides will have similar properties to what, and lutetium will have similar properties to what. Okay, so basically you have to find out what is this element and what is this element. Okay, anyone? This belongs to which period? Okay, let me tell you. Here element which is present next previous to it is calcium, and here the element present is aluminium. So it is similar to calcium and the higher members will be similar to aluminium. Okay. Okay, so yes students, now I am available to answer your questions. So whatever doubts you have regarding your preparation, you can put down your questions in the comment section. I will answer them one by one. Okay, so Prabhak Jeevan, ma'am, what to do if I start chemistry now? Please tell me strategy, please. So Prabhak, if you want to start from now onwards, you can watch my PU2 series of 1 marker, 2 plus 3 marker, 5 marker numericals. Okay, that will really help you to do a lot of questions. Okay, so first complete that much and then solve model papers. That will be enough for the starting phase. Okay, okay, Mohammed has a question here. So Mohammed, I think you have written like this, BO2 plus, right? or is it VO2 plus? I'll tell for both how to calculate. Okay, so vanadium I will take X, oxygen is -2, so -2 into 2 it is -4, this is +1, right? So vanadium will get +5 here. Okay, if I'm writing this as the compound, and if you have here VO2 plus, then I have X for vanadium, oxygen is -2 and this is +2, right? So this -2 will shift here, so X will become +4. Okay. Pawan DV, ma'am, physical chemistry. Pawan, physical chemistry means what is your question? What is your question, Pawan? Please make it clear. Isha, ma'am, how to study organic chemistry? So Isha, organic chemistry, you have to remember a lot of reactions. So please make a flow chart of the reactions. Take that step first of all. Make the flow chart. For making flow chart, you can refer to my 60 out of 60 KCET videos. Okay, and see the organic chapter. I have drawn the flow chart. So please draw the flow charts and then look at those and practice conversion questions. Okay, then chapter wise make a list of name reactions, chapter wise make a list of mechanisms. Okay, and then do practice of these questions again and again, you will be able to get it. Okay. Sanu, ma'am, what about numericals? Dear, numericals are very easy. You just have to remember formulas. Okay, I have a video where I have discussed almost 30-40 numericals. So please do those questions, practice those numericals with me. You will know which formula you have to put and then easily you can get it. Okay. Vishnu, you can refer to my all 2+3 marker video session. There I have discussed coordination compounds, all the important questions. Okay. Okay, Kirtana, for getting 110 plus, so you have to cover both PU1 and PU2 syllabus. Okay, PU1 and PU2 syllabus, if you do completely last 10 years of questions, then yes, it is possible. Okay. One second. Okay, I understood. This is wrong. I think I did a mistake here. Yes, this one, right? Okay, so here I forgot to mention this +1. So yes, you are correct here. Yes, Mohammed, you are correct. So it is X -4 is equal to +1. Okay, it is like VO2 plus. So I have X -4 is equal to +1. So X will be equal to +5. Okay, so this is +5. Yes. Varija, relative lowering of vapor pressure numericals are very difficult. Why, dear? You can just put the formula, right? In relative lowering of vapor pressure, please remember one thing, delta P by P naught is equal to XB, right? And in this XB, you can just put NB by NA. You don't have to consider this NB. If you have to ignore this NB, okay? Then calculations will be easier, okay? Yes, Shabba Reddy, please ask your question. Thank you, Isha. Thank you so much. Sanu, please put down your question in full sentence. I'm not getting. Yes, students, do let me know if you have any other problem. So students, tell me, how is our marathon sessions going on? Are you finding them useful? The 1 marker, 2+3, 5 marker, 2+3 marker, all numericals, passing package, everything we have already done, and some subjects I think might be there, it will also be done. So yes, tell me, how is the feedback? Are you finding these videos helpful for your preparation or not? Okay, Varija, I'll make a video on this. Okay, how can you calculate log and anti-log using calculator? But please remember, for log and anti-log you have to use the log table, that will be easier. And in the examination hall, if you ask for log table, the examiner has to provide you. So please make sure that you use the log table, that is more easy and convenient way. And if you want to know how to use log and anti-log table, I have a very detailed video on how to use log table and anti-log table, you can watch that, okay. But yes, you can easily ask for log table in the examination hall, okay. Yes, Vishnu, definitely CBSE students can also watch this. Okay, Kirtana, MTG objective KCET books MCQs we will do definitely. Okay. Kirtana, for crash course on KCET you have to contact to the number that I have given you, right? You can see here. Just a minute. Yes, you can call on this number and you can clarify all your doubts. Fees and everything will be told to you on the call, so you can contact them, okay. Yes, Sanu, definitely you can depend on model paper. And even I'll say you have to solve all the 3 model papers, that is a must. Do not go to the exam without solving model papers, because you can find similar questions in the exam. Shabba Reddy, what is oxidation state? So Shabba Reddy, see, in a compound, okay, each element has a charge, okay. In a compound, each element, suppose a compound is made up of more than one element, right? 2 or 3 elements have been mixed, suppose. Each element in a compound has a individual charge, and that individual charge of an element in a compound is called as oxidation number, okay. Question number 46, definitely we will repeat. Question number 46. Okay, so see here, so you have to correct in the increasing order of oxidizing power, okay. Now what did I told you? Oxidizing power is proportional to oxidation number, okay, like inversely proportional to oxidation number, okay. So one second, sorry, one second. Oxidizing power is directly proportional to oxidation state, okay. Higher the oxidation state, better oxidizing power it will have. Now we have calculated the oxidizing power of all the 3 elements. For vanadium it is +5, chromium +6, manganese it is +7. So higher the oxidation state, better is the oxidizing power. So definitely MnO4- will be the element which or the compound having strongest oxidizing power, and the least one will be your VO2+, okay. I hope Shabba Reddy it is clear. Is it clear? Okay, okay dear, thank you so much. Students, okay, Kirtana, thank you so much. Sanu, there are some questions, they are fixed, okay. Like your from alcohols chapter, the out of 3 mechanisms, any one will be asked. In chemical kinetics, the derivation of 0th order or 1st order will be asked. There are some questions which are fixed, there are some questions which are not fixed, okay. Sanu, no, model paper questions, if you complete the chapter thoroughly, if you read my Brahmastra series, please do once and then go and attempt the model paper, definitely you will find it very, very easy. In model question paper, yes, definitely some questions are little bit, I can say, out of the box, but yes, again it is not difficult, you just have to go through all the sections of the chapter. Okay. Any more questions, students? You can ask me any more questions, or if you want any other help, you want us to do any other videos for you people, you can put that also in the comment section. We are always like waiting for your comments to see what is your response. So please show that to us in the comment section, and whatever you want will be provided. Okay. Okay, that's all students. I think you all have to go and prepare for your Kannada exam. So I hope all of you are really studying hard. So if you are panic, if you are nervous, do not worry. It is the condition of all the students at this point of time, but make sure that you are utilizing your time effectively. Okay, do not waste a single minute. Plan your preparation and then study. Study the high weightage topics first. Okay, I hope with this I can end the session. Okay students, take care, all the very best for all of you. Okay, fine, chalo, bye bye students, good night, take care, and please remember we have to study really hard for our exams. Okay, chalo, bye bye all of you, take care.